Through this. So what we learned in our reading is that, you guys need to be quiet, is that when you multiply bases, you add their exponents. So what we can do is we can rewrite this as two separate logs, log of A plus log of B. When we divide bases, we subtract exponents. So again, this is like log of A minus log of B, okay? The third one, when you take an exponent, because logarithms really are exponents, to an exponent, you multiply. So you multiply this exponent times your log, because your log is. Now, the change of base, watch. We can do log of, say, 100. We can do that. We can do, because it's base 10 on our calculator. But if it's base, any other base, let's say it's log of base 5 of 100, okay? That you cannot do on your calculus. And there are some fancy calculators. Jose? Okay. This one you cannot, there are some calculators will do this, but a lot of calculators can't. So what we do is this, to change the base, set it equal to x. Let's rewrite this, exponential form. We'll go 5 to the x, 5 to the x equals 100. Okay, I just changed it from log form to exponential form. Went base to the exponent equals the answer. Okay, now what we're going to do from here is we're going to take the log of both sides. When I say the log, I'm just going to go log of this and log of this. When I take the log of both sides, we are going to apply this rule right here. This rule says you can float down the exponent, okay? So when we take a log of a base to an exponent, the exponent will come down. So we float down the exponent. We'll bring this x down. We'll go x log of 5 equals log of 100. Okay, now I'm going to stop for a second. I didn't write the base on purpose because the base I want to use is my calculator base. I could not do this original problem without using a special calculator. The only thing I can use is base 10. Now all of a sudden it is base 10. So now to solve for x, I'm going to divide by log of 5. Divide by log of 5. Okay, now let's check this out. What I did for the change of base is I took the log of 100 and I divided it by the log of 5. Okay, so if I want to do this, I'm going to take the log of this number divided by the log of this number, and I can use my calculator now to find out what it is. So if I go log, now this is calculator log now, log of 100, to close the parentheses, divided by log of 5, I get an answer of about 2.86, okay? So if I were to try and take the log of base 5 of 100, it'd be about a 2.86, or 5 to the 2.86 blah 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 should equal 100. Okay, let's check it out. 5 to the power is about 100, okay? So backing up, what I have is a base 5. Cannot use your calculator, but I changed it to log of 100 divided by log of 5, right? Log of 100 divided by log of 5. These are my calculator bases. I used my calculator and I got the answer. Okay, now let's keep going. Okay, let's keep going because I'm going to talk more about this later, all right? So let's look at, first of all, I will try to put this up here every time. Okay, that's our log form and our exponential form, and we've learned that they go back and forth. You can change it from log form into exponential form, right? And you can go from exponential form to log form. So you can go back and forth between one form and the other, right? Now, example 1, we want to apply our rules, okay? So the first rule I have is if I add two logs, I can rewrite it as a single log by multiplying the bases. So I'm going to apply this rule right here. So I'm going to rewrite this as log base 4 of 2 times 32. So because it's plus here, we can rewrite it as a single log by multiplying the bases, all right? That's all I did. So plus here, I can rewrite as a single log by multiplying. So that's going to be log base 4 of 64. Okay, now, 4 to what power? 4 to what power? 4 to what power equals 64? 3. So this answer is 3. 4 to what power equals 64? See how logs work? So log base 4 of 64 is looking for the exponent, right? It's looking for the exponent. The exponent is 3. Logs are exponents. Okay, B, let's apply the other rule. So the other rule is when I subtract them, okay? So if I go log of A minus log of B, I'm going to bring it together. Instead of minus, I'm going to do a division between the two bases. So I'm going to rewrite this as log base 2 of 80 divided by 5. So the subtract between the two logs, when I bring it together, I'm going to divide, okay? So let me rewrite that. That's going to be log base 2, 80 divided by 5 is 16. Okay. Now we can still go further with this, okay? 2 to what power equals 16? 4. So this has to be 4. This has to equal 4 because we're looking for the exponent, right? 2 to what power? 2 to the 4th power equals 16. See how I do that? Because logarithms are exponents. So 2 to what's the exponent? 4. Okay, C. What we're going to do on C is this. We're going to use the third rule, but we're going to go from this way to this way. So we have a number out in front. It was an exponent. It got floated down. So now I'm going to bring the exponent back up and in. So, Jose, I'm going to go like this. I'm going to bring this exponent back up and in, okay? So I'm going to rewrite this as log of 8 to the negative 1/3. So if you have a number out in front, you've got an exponent, you've got a number times an exponent. So it's going to be an exponent to an exponent. So I brought the exponent back in. Okay? So the number out in front of the log multiplied was an exponent. The number out in front was an exponent. Now, what is 8 to the negative 1/3 power? It is going to be 1/2. Totally right. Okay, it is 1/2. And we're just going to leave it as 1/2 because we don't have a base on this one. Okay, D. All right. If it says plus, let's bring it together. Oh, we can't. You know why we can't bring it together? Different bases. In fact, let's highlight that. So on these two, we can't do it. We can't bring them together because we have different bases. So we have to do them individually. So let's take a look at this individually. Let's put a little like that. Let's first figure out what is log base 2 of 32. Okay, what is that answer? Anybody know it? What is log base 2 of 32? 5. How'd you get 5? 5 is totally right. How'd you get 5? 2 what power equals 32? 2 to what power? 2 to what power is so it's 5. Very good. Okay. Log base 3 of 81. What's that answer?
9.
7.
3. 4. 5.
Thank you. 4.
Oh, it's so close.
3 to what power equals 81? Thanks, Raul. 3 to what power, right?
Times 3 is 27.
Times 3 is 81. So 3 times 3 is 9. Times 3 is 27. Times 3 is 81. So this one's got to be 4. So now I know this is 5. This is 4. What's 5 plus 4? 9. So somebody did say 9, but yeah, eventually 9, right? Okay. Example 2 says expand the expression. Now, to expand it, what we're going to do is this. I want you to imagine, and I know you know, there's a little time sign. There's a little time sign between the 6 and the x, right? 6x means 6 times x, right? So I'm going to take this multiplication part here and expand it to 2 logs being added together. So I'm going to rewrite this as log base 2 of 6 plus log base 2 of x. That is it in expanded form, okay? Okay, let's look at B. I'm going to run out of room. That's right. Now, there's a time sign right here. Now, you don't really normally write the time sign, but there's a time sign there, right? So same thing. If it's multiplying 2 bases, I'm going to rewrite it, break it apart, okay? I'm going to break it apart as the first log plus the second log, okay? So I'm going to rewrite this using our rule. Log base 5 of an x cubed plus log base 5 of y to the 6th. That's a power 6. Sorry about that. Okay, I'm not done. I'm almost done. But now I want to use this power rule, where if I have an exponent, I'm going to bring the exponent down and out. So I'm going to use this rule. I'm going to take this exponent down. So I'm going to float down the 3. Okay, I'm going to take this 3, bring it down. I'm going to take this 6 and bring it down. So I'm going to rewrite this as 3 log base 5 of x plus 6 log base 5 of y. Okay, so these little tricks become really important in calculus. I know you're not taking calculus right now, but if you do take calculus, you're going to have some horrendously ugly problems that you're going to need to simplify, and it becomes 3 or 2 easy problems in calculus instead of one big complicated. So in calculus on C, if you had to do a thing called a derivative on C, it's really difficult. But if you break it up, it becomes 3 easy problems. So how are we going to break it up? First, I'm going to rewrite this. And I'm running out of room. Here we go. ln of A plus ln of B minus ln of C to the 1/3 power. Okay, I know that's squished in there, but okay. So what did I do? I've got a multiplication between A and B, right? There's an A times a B, so I rewrote it as ln of A plus ln of B. There's a division, right? There's a division, so I rewrote this as minus the ln of C. Now where did the 1/3 power come from? What the heck? It's the cube root, right? Cube root's a 1/3 power, right? Okay, now I've got just one last thing to do to simplify this, and that is to float the 1/3 down. Float down the exponent. Okay, we're going to use this rule. We have an exponent with a log, we can bring it down. Okay, so let's rewrite this as ln of A plus ln of B minus a 1/3 ln of C. That's the simplified version of our problem. Okay, all right, you ready to turn the page?
Yeah.
Okay. All right, now we're going to go just the opposite. So instead of it, now it's expanded, and we're going to bring it back and rewrite as a single log. Okay. So to rewrite as a single log. Single log. Start right here. Go log. We're going to go. And we're going to have an answer of log. So the first thing I'm going to do is this. I'm going to bring.
Can't see.
Oh, that's not good. First thing I'm going to do.
Still can't see.
Oh, that's there. How's that? Thanks. I'm going to bring back in my exponents. I'm going to bring back in my exponents. Okay. So my exponents that were on the outside, I'm going to bring them back in and up as an exponent. Okay. So I'm going to rewrite this as log of x to the 3rd plus log of y to the 1/2 power minus log z squared. Okay, all I did was brought in the exponents. Okay, this was an exponent. This was an exponent that got floated down. I brought it back in. This was an exponent. Okay, it was an exponent. I floated it back in. This was an exponent. Brought it in. Okay, now what am I going to do? Well, if it's plus, I'm going to multiply. If it's subtract, I'm going to divide. Now we need a single log, so write log. Big parentheses, okay, because we need it as a single log. Log of what? Log of what? Well, it's going to be log of x cubed times the square root of y over z squared. Okay, here's my plus. Comes to a times when we bring them together. Here's my subtract, which comes here. There's a divide. My 1/2 power I rewrote as a square root. Okay, guys, ready for B? Let's do the same thing. Let's float back in our exponents. So bring our exponents back in. Bring our exponents back in, right? So I'm going to rewrite this as ln x cubed plus natural log of y to the 1/2 power minus natural log of x squared plus 1 to the 4th power, okay? So the first step I have to do is bring back in the exponents. The exponents got floated down originally. I need to bring them back in, okay? Now I need a single log, so I'm going to write as ln of, well, what goes inside the parentheses, right? Yep, I hear x cubed times, I don't need the times sign, but I'm going to put it in there anyway, square root of y, right? Divided by x plus 1 to the 4th power, okay? Here's my plus, which is now times. Here's my subtract, which is now divide, okay? That's not so bad.
So you just take the square root of y and turn it to 1/2.
Yeah, 1/2 power, a 1/2 power is the square root, okay?
But could you take
Right.
it as the 1/2? Or do
You
want
could.
it as the square?
I wouldn't mark it wrong if you kept it as a 1/2 power. I wouldn't. You need to know that it's a 1/2 is square root, because you're going to definitely need to know that when you go to calculus, okay? All right, 4. Here we go. Now, 2 ways to do this one, okay? One is really a pain, okay? 5 to the x equals 3. So, you ready? We can guess and check. 5 to the 2.1 power. Pretty close, right? 5 to the 2.11 power. I'm a little closer. But guess and check's a real pain, right? We can do this exactly with logarithms, okay? Here's how I'm going to do it. Okay, first of all, let's change it into a log. Let's change it to a log. So let's go log base 5 of 30 equals x, okay? Now we learn this thing called the change of base formula, okay? So our change of base formula says we're going to take the log of this number divided by the log of the base, okay? So we're going to take, to get x, it's going to equal log of 30 divided by log of 5. That's our change of base. Now,
6.
it's not. You gotta be careful. It's not log of 6. What's the base? I didn't write a base. What's the base?
10.
I like that. Why do I like 10?
That's the base.
I put in my calculator, right? If it's base 5, I can't. Well, some of you can. Some of you have fancy calculators. But base 10 for sure. So I'm just going to go, all right, what is?
Just doing it divided by 2.
You can't. No, it doesn't work that way because these are exponents.
Oh.
And they're going to follow exponent rules. That's why you can't divide. They're going to follow exponent rules, okay? So log of 30, oops, 30, close the parentheses, divided by log 5, close your parentheses. So we got about a 2.113. I was close on guess and check though, right? 2.113, blah, 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 okay? Okay? All right?
We were so close, Mrs. Lee.
I was. Guess and check was pretty good. But you know what? I'm not going to guess.
I think it's because you knew the answer.
Did you get faster?
I got, yeah, and then dialed down.
But you're a genius. Come on. Okay, what do you think about B? What do you think you're going to do with B?
You're
Yeah,
gonna,
change it to exponential one.
We can, but why don't we go straight to change? Yes, by the way, yes. Change of base. Okay, so how does the change of base work? Do you remember?
you divide the thingy by the other one.
Log 5 divided by log 8. It's the log of this one divided by the log of the base. That's how you do it. Now what base am I using?
10.
Yeah, because I can use my calculator, right? So I'm just going to type in, what's log 5, close your parentheses, divided by log 8, close your parentheses, and I get about 0.774. Right? Almost there. Okay, and C. Get rid of that 3 first. Right? Get rid of the 3. How do you get rid of the 3? Yeah, it's divide by 3. So I've got 2 to the x equals 9, right? Let's change it to log. Change into log form. So we'll write log 2 is the base of 9 equals x, okay? So we can't do base 2 on a calculator. So we want to change it to calculate a base, so we go, how am I going to write this? Log of
2.
9.
Divided by log of 2.
That's it. That's all we got to do. And log 9, close your parentheses. If you don't close your parentheses, you're going to get a weird answer, okay? You got to close your parentheses. Divided by log 2, and I get an answer about 3.17. Okay, here is our homework for today, and I'm going to help you. It's not, it goes really fast. Okay, and maybe we can do it together and possibly